In grade 10, we solved trig equations where the solutions were always in the first quadrant. So the question would always say solve for theta, and theta lay between 0 and 90. So it was a quadrant 1 angle. So just a quick revision of how we're going to work and solve trig equations. The first thing, if you remember from last year, was we had to isolate the trig function. So the trig function, which is the sine theta, must be left alone on the left-hand side. So what we're going to have to do is we're going to use equation rules to do that. So this is one term. So to get rid of 2 times, we're going to divide both sides by 2. And we're going to end up with sine theta is equal to 1/2. Okay, after the trig function was isolated, we then tried to get rid of the sine, and we did the inverse, which would be arc sine. So we move this to this side, and we'd end up with theta is equal to arc sine 1/2. Okay. Okay, now sine minus 1 is on your sine button, and you have to press shift and sine to get arc sine. And please make sure your calculator is in degrees. Because if it's not in degrees, you're not going to get the right answer for school. Okay, so when we do that on our calculator, we end up with theta is 30 degrees. So we have worked out that this is a 30-degree angle in the first quadrant there. Okay, now you know from this here that sine could also be positive 1/2 in another quadrant, and it would be in quadrant 2 because sine is positive in quadrant 2 as well. So this in grade 11 gets not just one solution, but it ends up with 2 solutions because there are 2 solutions to where sine would be equal to +1/2 in our revolution. All right, so we're going to work in 2 quadrants this year. And this would have been 30 degrees in the first quadrant. And where else is sine positive? Sine is positive in the second quadrant. So in the second quadrant, my angle would be 180 minus 30. So it would have been 150. So sine theta equals 1/2 would give you a solution of 30. That's called my reference angle, the small acute angle. And then there's always another solution in one of your other quadrants, which is always your reference angle. And then we use it on the cast diagram. Okay, so we're going to look at finding the general solutions to a trig equation. And these, I've just written the steps down, so we've got them as notes. The first thing we're going to do is we're going to isolate the trig function using your equation rules, which we did here. Okay, isolating the trig function. After we've isolated the trig function, we calculate the acute angle. Okay, now we call this a reference angle this year, by using your arc sine, arc cos, or arc tan to the numerical value on that should be the right-hand side, because it's normally on the right-hand side. Okay, don't include the negative sign. We're going to chat about that just now. Okay, number 3, look at the sign of the numerical value and decide which 2 quadrants you're going to be working in. Okay, and we're going to use a cast diagram for that. And then we're going to use these 4 combinations to give us the answers to our equations. Okay, so if we're working in quadrant 1, my angle would be equal to my reference angle plus k lots of 360. Okay, let's just look at that. So if I said to you, we said to you just now that our solution was 30 degrees in quadrant 1, and we decided that it would also be 150 degrees in quadrant 2. Let's just put it on 2 separate diagrams. Okay, so that, I'm talking about the one we did on the first page. So this is 30 degrees, and this is 150 degrees, because we said there would be 2 solutions. Okay, now what's happening in these funny looking things is that I'm saying that if it was 30 degrees, if I added 360, so I made K1, you would have exactly the same terminal arm. Or if I subtracted 360, you would have exactly the same terminal arm. And the same as 150. If I took the 150 degrees and I added 360 degrees, I end up in exactly the same place. So this k lots of 360 is like when we're reducing angles and they're too big, we can add and subtract 360 and it doesn't affect where the terminal arm is. And that's all this little part at the end is doing, this k lots of 360. Okay, so we're going to work through those steps. Probably didn't mean much until we actually look at them in terms of a diagram or of an example. So let's solve this. Find the general solution. That's that whole k lots of 360 thing that they're talking about. Whenever you solve a trig equation, the easiest way is just to find the general solution, whether they ask for it or not, and then work from that general solution. So what is our first step? Our first step is to isolate our trig function. And if we look at this, it's already alone. There's nothing in front of my sine, there's nothing divided into the sine theta, and there's nothing added or subtracted. So that's already done. Okay, then we use arc sine. So we get theta is equal to, because this is now going to jump over to this side like that. So on your calculator, we use sine and the shift button. Okay. And then what we have here is our reference angle. So what is our reference angle? Because that's what we're getting, the acute angle here. And that's going to be 60 degrees when you work that out. Okay. Now, I spoke about a sine in the, which quadrants are you working in? Okay, so here's your cos diagram. We have, you look at the line before you jump your sine minus 1 over here. So after you've isolated your trig function, what sine is in front of your ratio here before you find your reference angle here? Okay, so can you see that in front where that green dot is, there's a positive, well, it's invisible, but there is a positive sign there. So sine is positive. So which quadrants are we working in? We're working in quadrant 1 and 2. Okay, so you look at the sign in front of your ratio there to tell you which quadrants you're working in. And then we go off and we solve in the quadrants. So we have there, if it's quadrant 1 and quadrant 2, in quadrant 1, the answer, theta, is going to be the reference angle plus k lots of 360. Okay? So that's quadrant 1. 60 plus k lots of 360. In quadrant 2, your answer is going to be 180 minus your reference angle, because that's what's on your cast diagram, plus the k lots of 360. Because it doesn't matter how many times we add or subtract 360, we get the same angle. Okay, so that is finished. 60 plus k lots of 360. And this is going to be 120 plus k lots of 360. And what we have to remember is always we just have to say k has to be a whole number. So you've got to add or subtract whole amounts of 360. You can't add pieces of 360. So that's all this is saying. K must be an integer so that we're adding or subtracting 360 degrees every time. Okay, and those two are our general solutions. Right, so it's isolate your trig function, find your reference angle, and then you say which quadrants I'm working in, and then we use our little goodies that we remember to be able to find our general solutions. Okay, let's try another one. Tan theta is equal to -1. Okay, so the same steps again. We isolate our trig function. And again, it's already done. Tan theta is by itself. Okay. Ignore the negative sign. And find your reference angle. Okay, so this jumps over to this side. So theta is going to be tan minus 1 of 1. No negative in your reference angle. All right, and when we work that out, we're going to have reference angle is equal to 45 degrees. Okay. Now, we saw that tan was negative. Okay, tan was negative, which we had to ignore that. But that tells me which quadrants are we in when tan is negative? It's going to be quadrant 2 and 4. Because that is where tan is negative. Quadrant 2 and 4. So we write here 2 and we write here 4. And then we think about what is on our cast diagram in quadrant 2. So quadrant 2 is 180 minus. Quadrant 4 is 360 plus. And in this case, it's going to be reference angle. Oh, sorry, not 360 plus. 360 minus is in the fourth quadrant. And your reference angle. Okay, so these are our general solutions. So off we go. Theta is equal to 180 minus our reference angle. And then we always add plus k lots of 360. And in quadrant 4, theta is equal to 360 minus our reference angle plus k lots of 360. All right, so this is going to be, remember, only these can get put together. The k lots of 360 will stay alone. It's not a like term. So 135 plus k lots of 360. And the other solution in quadrant 4 would be 315 plus k lots of 360. Again, you're only adding those two terms. And remember we said that k always has to be an element of integers. So we always put that into our solution as well. All right, let's try one with cos. So isolate. All right, so we want to get this alone, the cos theta. So we're going to start using equation rules. We're going to add 1 to both sides. And then, because we have one term on each side, we're going to divide both sides by 2 to cancel that. And we have now isolated our trig function. So cos theta is going to be a half. Okay, so when we isolate our trig function, we use equation rules. All right, now we're going to find the reference angle, and we're going to be using arc cos. Okay, so this goes to this side. It's a positive sign in front here, so I don't have to worry about not including a sign. So this is going to be arc cos of a half. Okay, and then we find our reference angle. And reference angle is going to be 60 degrees. All right. But now we've got to think about which quadrants we're working in. All right, so if I look at the line before I did the arc cos, this is a positive there, positive in front. So cos is positive in quadrants 1 and 4. So those are the two that I have to write down here. That is where I'm solving. 1 and 4. Okay, so quadrant 1, hopefully you remember by now, it's our reference angle plus k lots of 360, and quadrant 4 is 360 minus the reference angle plus k lots of 360. Okay, you wouldn't normally write this on top here. I'm just reminding you what we have to write, and then we do our solutions. So what is our answer? Theta is equal to our reference angle plus k lots of 360. That's already solved. And here it's going to be 360 minus our reference angle plus k lots of 360. That's going to be 300 plus k lots of 360. Remember, these are the like terms. And we have to remember that k is an element of z. So those are our solutions. All right, just one more. Okay, steps again. Quickly through them. Isolate your trig function. So we're going to subtract the 2 from both sides because it's 2 terms. Negative 2. And then we're going to divide both sides by 5 to get the trig function by itself. So sine alpha is equal to negative 2 over 5. Okay. All right, so let's just check here. Sine is negative. So which quadrants are we in? Would be quadrant 3 and 4. And now we jump the sign over, and remember, no negative in reference angle. Don't put the negative in there. You're going to get the wrong reference angle. All right, so what is it going to be? And we normally round our reference angle to 2 decimal places. So shift sine 2 over 5. And we're going to have 23,58 degrees. So that's my little reference angle. All right, where are my quadrants? We said here. So quadrant 3 and quadrant 4 is where sine is negative. What did quadrant 3 say? It said that it is 180 plus the reference angle plus k lots of 360. And what does quadrant 4 say? Alpha is going to be 360 minus the reference angle plus k lots of 360. And again, these are the like terms. So this is going to be 203,58 plus k lots of 360. And this one's going to be 360 minus 23.58. 336,42 plus k lots of 360. And k has to be an element of an integer. It's got to be a positive or negative whole number. So we just pop that in there. Sorry, that's very messy. Let me try it again. K is an element of z. All right, so it's isolate your trig function, work out which quadrant you're working in, work out your reference angle, and then do your solutions in your quadrants.